Hello and welcome, my name is Matthias, and in this After Effects tutorial for marmoworld.com we are going to take a look at the elastic iExpressions that are part of the physics bundle. So this is all about animating elements in an elastic, wobbly way with the help of these expressions. So let's first take a look at the iExpression tool. This is this one here, and in the library it comes with a lot of different expressions, and in the physics category you now find in the slower category different elastic iExpressions, elastic connections, so you can link one property to another one for 1D, 2D or 3D properties, and elastic keyframes, which means a property moves according to its own keyframes and is not connected to another one, but does it in an elastic way. These expressions are in the slower category, but this does not necessarily mean that they always compute super slow, but it highly depends on how you use them. So you can use them in more efficient or in less efficient ways. And one important aspect of this tutorial is that I'm going to explain you how to keep them as fast as possible. But now let's start with the elastic keyframes. So I have here a background layer in this composition, and I have this icon that we are going to use later, and we have this one that we now want to move in an elastic way. And we do it by first setting some keyframes. Let's say we start at the here after 50 frames, for example. We start at this point, and then it pretty quickly moves here, and then it stays here for a while, let's say until here. And now let's also add some curved movement, and maybe let me make some space here. Let's say then it moves to here and further to here, maybe just to get some interesting curved motion such that you can also see how it behaves on curves, maybe like this. Okay, so this is the animation that we have for now, pretty basic. And maybe let me just set my work area to end here. So now it moves down, and now we have here this curved movement. And obviously this keyframe movement is not elastic at all. And now you can apply to the position this expression, and for now we keep all values at the default. And let's see how it is looking with the expression applied. So you can see when the text stops here, you have this nice elastic bouncing behavior. And then also here at this point you can see it's like rotating a bit like in a circle. So this is an important difference to other simpler elastic things that you might use, that here you have a true physics simulation, that if your animation ends in such a curve, then you can see here at the end it nicely has such a like circular bouncing and not just a back and forth bouncing. Yeah, this makes it really realistic. This is the reason why this computes a bit slower than other things, because it's really a true physics simulation that is going on here. Okay, so this is the basic idea. Keyframe your movement, apply the elastic keyframes expression, and it gets all a bit bouncy and elastic. You can think of it like connect this object with a rubber band to its keyframes, that it's not following it exactly, but it's really following it connected by this rubber band. Okay, the expression has three main parameters, which are the simulation start frames that are important for efficiency, and the softness and the damping, which are important to control how exactly this elastic behavior should be. So let's first take a quick look at softness and damping. So default is that softness is quite high, and the smaller I make softness, it's like the closer the object always has to be to its keyframe. So if you make it not soft, then the object is always pushed very strongly towards its keyframes, which results in a faster and more jittery behavior. So for some demo, let's set this here to 10, for example, and apply it again, or maybe also enable auto apply that whenever we change here something, it's automatically applied. So let's take a look how this is looking like. Softness of 10. So you can see it's pretty fast and jittery. And now, even when it moves to this point here, it's like moving back and forth always a bit, yeah? You can see now here, it's like a bit jittery, moving back and forth, because it's like already during the movement swinging back and forth moving back and forth around the keyframe position. Yeah, it's like very fast and maybe even a bit abrupt movement. If I make the softness very small, you can even lower this effect or increase this effect by lowering the damping, which like compensates this jittering. So let me just try to set this damping here to 5 and see what's happening. Now it should jitter even much more. You can have very fast, quick back and forth movements. And it takes much longer until the element stops jittering. On the other hand, if you increase the damping to something very high, you can see it is not swinging back and forth much. In fact, now the swinging back and forth is completely reduced. And if we also now make the softness again quite high, let's see what happens now. Now you can see we have a pretty smooth movement. Yeah, at the end it gets pretty slow. Yeah, but it's not swinging back and forth anymore because we have a quite high damping. Yeah, so if I make a small softness, it's not that at the end it slows down. Like here, you can see it nicely slows down. Also here, it's like a little bit like an easy ease. Yeah, because if you have a very soft rubber band at the beginning and at the end of the movements, the rubber band is compensating and it's very slow and nice easing, so to speak. But I think what you usually want to have is a high softness and a small damping, like something like 20% or so. And then you have this nice swinging elastic thing that I think you really want to have most of the time. Yeah, so my rule of thumb is a little bit keep the two together, like 80 plus 20 at the region of 100. So in other words, if you don't want much softness, increase the damping. But 80-20 I think is usually a good balance. Maybe sometimes you want to have something like 70-30, or I mean, play with the values of whether what better fits to your needs. Yeah. So, but in general, if you increase the softness, usually you also want to decrease the damping to compensate. Besides softness and damping, also simulation start frames is a very important parameter, and in particular for efficiency. So if you feel, why is my expression so slow? Play with the simulation start frames parameter and do what I'm explaining you now. So the first important observation that we can have here is that during the first 50 frames, nothing is happening. Yeah, this means we really just need to start our simulation at that point where the object starts to move. So we can safely enter here something like 50, and now you can see nothing has changed in the animation, but it will compute much, much faster because it doesn't need to calculate the 50 first frames. And to explain you in a bit more detail what is going on behind the scenes, it is like from each frame on, everything that happened before this frame must be recalculated. So in other words, if your simulation start frame is 50, and we are at frame 100, everything what happened from frame 50 to frame 100 needs to be computed for this particular frame. And if you are at frame 200, everything from frame 50 to 200 gets computed. Yeah? And if you are at frame 10,000, everything from 50 to 10,000 needs to be recomputed. This means the longer your animation gets, the slower it gets. And what can we do against this? We can restart our animation, because we have essentially here two different animations. This here is the first part, and then this here is the second part. And for the second part, there is really no need for every frame of the second part to re-simulate everything that happened in this first part here. Yeah? Just because, well, at this region in between, there is no movement at all, and whatever happens here is completely independent of what happened during this first movement. How is this working? We can make sure that we just select this layer with no properties selected and then click on this link icon. And now it asks, do you want to create a new slider for this? And I say yes. And now we do not have just one simulation start frame, but we can set here several simulation starts. And if we look at our movements, our first movement starts at frame 50. Yeah? Our second movement, this one here, starts at frame 150. So this means we need 2 keyframes and say, well, at this point, the simulation start should be 50. Now I set a keyframe and go here and say at this point, the simulation start frame should be 150. And now it's very important that we turn these keyframes by right-clicking on them and say toggle hold frame into hold keyframes. Yeah? If you now look at the number, it's in this entire region, it's keyframed to be 50. This means everything that is animated here, yeah, is simulated starting from frame 50. And now the second part is independent. And for this entire movement, for the computation of this movement, we just start looking at frame 150 because it's completely independent. Yeah? And now we can even go one step further and say, after this second animation here, now at this point, this animation is completely stopped. There is no need to simulate anything at all. So let's say our animation has 1000 frames here in total. So we can, from that point on, set it to, let's say, 9000, for example. So it's way behind the end of the scene. And then this means, well, at this point in time, there is no need to simulate anything at all, which means the expression will dramatically faster do her computation in that case. Yeah? So this is really a point where it makes sense to shut or turn the expression on and off by setting this slider simulation start behind the current time. Yeah? Because then you only simulate the regions where you really need the simulation, and then you can also have compositions with thousands of frames length if you restart from time to time and turn off the computation with the help of this simulation start frame slider in regions where no simulation is necessary. As a rule of thumb, the longer the regions are in which you simulate, the slower the computation will get. So far you've learned how to make some keyframed movement elastic, and now I want to show you how to connect one property to another one in an elastic way. What we want to do here, we want this iExpressions icon first to move a bit, and then the spring icon here should follow it in an elastic way. So let's first start with making this move here quickly, and an easy way to make it move is to just apply a wiggle expression. Of course, you can also keyframe some paths. I've chosen here the separate wiggle 2D because then I can say in X direction it should wiggle 500 pixels and in Y only 250. Frequency is like the speed of this movement. Yeah, I apply it. And now it's like the iExpression icon is moving on the screen here in a really random way. And what we now want to do is we want to link this spring to this icon. Yeah? And we do this again with one of the elastic iExpressions. So here's our library. In the physics simulation, we have in the slower category the elastic expressions. Before we've used the elastic keyframes, and these work with arbitrary properties, no matter whether it's a 2D position of a layer or a 3D position or like the rotation of a layer, whatever. But if you do the elastic connection, you have 3 different choices depending on what property you have. Yeah, in this case, we want to link the position of a 2D layer to the position of another 2D layer. So it's a 2D value that we link. Therefore, we need the elastic connection 2D. If you want to link something like the rotation, a 1D value, you choose this one. If you have positions of 3D layers, you choose this one. So we go here with the 2D variant. Click OK. Oh, I have here the second library open. And now this looks pretty similar to the elastic keyframes expression, except that it has 2 additional properties. The link to property. Obviously, we want to link the elastic icon here to the iExpressions icon. So we select the position of the iExpressions icon and click link to mean this is a property that we want to follow. And then we go to the elastic icon and apply. And if we take a look at ramp preview, this looks as follows. So this is really not too exciting. It's like the spring is randomly moving like the iExpressions icon also, yeah, no big deal. At the beginning, you see here this very strong bouncing back and forth, and this is because the spring starts here and the iExpression starts here, and so at the beginning it like bam starts overshooting quite a lot like this. Yeah, this is what you see here in the very first frames, and then it somehow stabilizes and follows the iExpression icon in an elastic way. What makes this really more interesting than the simple elastic keyframes expression is this additional strap length. And this is like you can imagine that the rubber band that connects these two elements here is not 100% elastic, but you can tell it something like I have a 300 pixels long piece in it that is not elastic. In other words, as soon as the distance between the two is less than 300 pixels, it stops pulling the spring towards the iExpression icon. Yeah? So if we reapply this, let's take a look at how this is looking. Now you can see now the spring is not always moving with the icon, but only if the distance gets larger than 300 pixels, then it's like the iExpression icon is pulling the spring towards itself. And again, you can see at the very beginning now this very heavy behavior. Again, this is because the spring is yet so far away. If we start with the spring being very close to the iExpression icon, you avoid this heavy bouncing at the beginning. Okay, and now again we can, for example, play here with the softness and damping parameters. If we want that to be less damped, so to speak, I can lower this, for example, to 5 and reapply it. Let's see how this is looking like. And now you can see the spring is moving much more. Yeah, it's not slowing down so much anymore. It's not so slack maybe. And in total, it's like it's having more energy. Not so much energy is lost all the time. It's like the spring is moving all the time. Yeah, this is what you can control with the damping. And then with the softness, again, you can control how quickly it should follow. So maybe let's do another experiment and also lower here the softness to a very low value, maybe something like 30. And now you can see we have a really bouncy, very fast animation around the eye. Yeah, in general, we have this rule of thumb. Whenever you have little softness, increase the damping to compensate it. So let's say we put here a damping of 50. And now we should get a really like slack but not bouncy movement. Yeah, so if it's too bouncy, increase the damping. If you don't have, if you feel it's like elastic enough, if it's following too fast, increase the softness. Then for the simulation start times, again, you can link this to a slider to restart the animation. Just the only thing that you have to keep in mind there is if you restart the animation, the position of the following item does not continue from the position where the last simulation ended, but it starts at the actual keyframe position. Yeah, in other words, whenever you set a new simulation start frame, at this point also set a new keyframe for the position of the object, is to say from where this new simulation should start now. Another thing that I want to share with you is that this expression can be very nicely combined with a look at expression. So let me open this expression in the library. In the layer placement bundle, you find the layer orientation, and there is a look at point 2D. Obviously, if you have 3D layers, you should use look at point 3D. And let me choose this expression, click OK here. And then all you need to do is to say, I want to look at the position of this object that I follow. So you select the position of the iExpression icon here and link it to the look at. And then you select this layer, no property of it, just the layer, and click on Apply. And now you can see the spring rotated. And if you take a look at the RAM preview, you can see it always looks towards the icon that it is following, which is pretty nice, I think. And still you can control how exactly it is following it. So let's say you don't want this end to look towards this icon, but the other one. Then you can simply go to the rotation to which this is applied and just rotate it the other way, like this. And now it looks towards it always with this end of the spring. So this is just a nice little tip to combine these elastic expressions with the look at iExpressions. So now you've seen the 2D variant, and the elastic connection 3D is essentially the same for 3D layers. And here I already have prepared this iExpressions icon moving in 3D space. Again, I've just applied some wiggle expression to it, and you can see it moves in 3D space. And now in the exact same way, you can say I link to this position my elastic connection 3D by clicking here on this link icon, setting my parameters, like for example, again, I want to have a strap length of 300 pixels and apply it to the position of this other element, apply. And now if you take a look at the RAM preview, you can see the spring is now pulled by the iExpression icon through 3D space and is always following the iExpressions icon in this elastic fashion. So in that sense, the 3D version works exactly as the 2D version, just that it's fully simulating everything in 3D space. The last expression that I want to show you is the elastic connection 1D, and this we are going to use to rotate layers in 3D space, and we want to link the rotation of one element elastically to the rotation of another element. How is this going to work? First of all, I have here prepared some very basic composition that just consists of a background, and then I have this slide here and this slide, and the first thing I want to do is I want the one slide to become the back side of the other one. So I turn both of them into 3D layers and go to their rotation. And for the second one, I use the X rotation to rotate it upside down, 180 degrees. And then I go to the position and push it a bit in depth such that it's laying like just 1 pixel behind the other one. Now I take the 2 layers and go to layer precompose and call this slide, for example. And now the important thing is that I set collapse transformation, this sun icon here, to on. And now if I make this a 3D layer and rotate it, you can see we have now a nice layer with 2 sides. And now let's say I want to cut this into slices, and to keep it simple, I just use 2 slices. Let me set the rotation here back to 0. So I just draw a mask here for the first slice, and then I duplicate the layer, Control D, and in the second one for the mask, I set the mode not to add, but to subtract. And now I have 2 elements, and if I rotate them, you can see here I only rotate the first half of the element, and here I only rotate the second half. Now we don't want to rotate the second half manually, but we want to link the rotation of it to the first one. So this means we just select the rotation of the first slide here and actually give these individual names. So let's call this here slide 2 and this here slide 1, because if we have layers, it's important they have unique names when we use expressions like iExpressions. And we take the X rotation here, say link to this one, and go to the X rotation of the second one and apply it. And if we now keyframe some movement here in the first one, so rotation, let's say at the beginning we have a rotation of 0, and then 2 frames later we have a rotation of 60, like this. Let's take a look at how this is looking like. So you can see the first one rotates very quickly, and the second one nicely follows in a bouncy way. And of course we can do the same also if we do a full rotation, 180 degrees, so that the second half is visible. And let's make it a bit slower. So let's say it's moving for 10 keyframes. And now you can see that the second half is following like this, and it's nicely bouncing back and forth. And you can even chain this, so you can like create not just 2 slides, but 3 or 4, for example. And then you can link the rotation of the third one to the second one, and the rotation of the fourth one to the third one, and so on. Just be aware that when you start creating these chains, everything is getting really slow. So more than 4 or 5 elements in a chain is really not realistic. Okay, I hope this gave you a good starting point to understand what you can do with the elastic iExpressions. And I'm really curious to see what you do with them. If you get creative and have something interesting to show, please leave some comment. I'm always interested to see what you do with our tools. And yeah, my name is Matthias. I hope you enjoyed this tutorial, and I'm looking forward to see you again in the next one.